Today I'm going to go over, this is Miss Owens, the Behaviors and Pseudocode slides, just like I did in class, so that you can have access to it. So first thing we did was we watched this introduction. So let's take a look at it. So we can all be thinking about behaviors and pseudocode together.
Behaviors are a very convenient way to talk about what the robot is doing. Looking for an obstacle. Behaviors are big. Some big. Some behaviors are small. Just identify the first behavior. Turning the other way. Each one of these smaller actions. Those down again. And over 2 minutes. Robot C has a command to turn on one motor. You reach a behavior that says turn on one motor. Take a look at the list you made. In the order and way you specify them, represent the plan that the robot needs to follow. You have a logical way to easily review the behaviors and the organization. Now let's talk about
So that should help you have an idea about the vocabulary that we're going to be working on, behaviors and pseudocode. Let's take a deeper look at the details now. Anything your robot does is a behavior. Turning on a single motor is a behavior, moving forward is a behavior, tracking a line is a behavior, or navigating a maze are behaviors. So the things that the robot does. We are concerned with three main types of behaviors. Basic behaviors, which is the most basic level. Simple behaviors, uses basic commands. And then complex behaviors, which is composed of the simple and basic behaviors. At the most basic level, everything in a program must be broken down into tiny behaviors that your robot can understand and perform directly. In VexCode VR, the program we're going to be using, that's virtual reality, you'll have a real robot that you get to control and move around. These behaviors are single statements like drive forward or turn right. Then we're going to look at the simple behaviors. This is the drive forward, which was the basic, and you're going to add some detail to it, like for 2 seconds. So you have the basic and you add the simple. So give it a little bit more information. Simple behaviors are small, bite sized behaviors that make your robot perform a simple yet significant task, like driving forward for a certain amount of time. These are the most useful behaviors because they are big enough that you can describe useful actions, but small enough that you can program them easily using basic VexCode VR commands. Complex behaviors, these are behaviors at the highest level, such as navigating the whole entire maze. So follow a defined path through the maze. Though they may seem complicated, one nice property of complex behaviors is that they are composed of simple behaviors. Here's how it's going to look in our programming. Example of all three behaviors broken down, the VexCode VR system. For the basic ones, it's going to be just drive forward. Then to simple, it's going to be for how long or how far. So that blue line adds a basic, and then you add a simple. To be more complex, it's the whole task. The most important idea in behaviors is that they can be built up or broken down into other behaviors. Complex behaviors like going through a maze can always be broken down to smaller, simpler behaviors. These are turn can be broken down farther and farther into reach basic behaviors that you recognize and can program. So first you think about what you're trying to do, the complex behavior. Then you have your simple behaviors about how it's going to happen. Go forward for 3 seconds, turn left 90 degrees, go forward for 5 seconds. You can see how this starts to sound like a maze because it's the simple behaviors are going to sound like the maze. And before you get to the simple ones, this is what had to happen. We had to have a robot drive forward and wait for 3 seconds, turn left for 90 degrees. So those basic ones had to come before the simple. So the pseudocode is that English language that's between programming and English. So you can easily look at each other's code and know what's going on. So when you work in teams, because everything we do in the world is in teams, people can read what you're trying to do quickly and try and find solutions if you're running into problems in your code. So the programmer is going to write basically like a rough draft or a plan, and then we'll turn it into the actual computer program language that we need. If you think back to the algorithms and making that paper airplane, do you remember how that man had his kids making all those details to make the sandwich? The end result was making the peanut butter and jelly sandwich. But then the kids had to write all those steps or the ramen noodles. And then you had to do it for the paper airplane. If you're not detailed, your robot won't do what you want. So for your assignment, I want you to answer these conclusion questions. Number 1, list 5 smaller behaviors that you can break down brushing my teeth into. So in the example, it was going through a maze. I want you to do brushing your teeth. Number 2, why is it important to think of a computer program as a set of basic, simple, and complex behaviors that a robot needs to follow? What do you think? Answer those 2 questions and turn them in. Thank you so much for participating in today's lesson on behaviors and pseudocode.